Okay, so we started going over the basic syntax of Python, and we also dedicated some time going more in depth about numbers in Python. Now let's start speaking about strings in Python and look more closely about how they work and what you can do with them. So first, let's notice that there are two different ways to define strings. In some programming languages, you have the single quote syntax, and in others, you have the double quote syntax. In Python, you can actually do both. So you can define it using a single quote or a double quote, as long as it starts and ends in the same kind of quotation mark. It's fine. And we also saw that we can use the plus operator to concatenate strings. So we have the first string, S1, and the second one, S2. And we can then concatenate and put them together with two additional strings. Now, even though you can use both the single and double quote, I actually recommend you to use the single quote, which is more like the convention in Python. So let's stick with this option. Now again, similar to many other languages, we have some special characters that we can define within strings. And we do it using the backslash syntax. So notice that this is a backslash. This is the keyboard key, typically above the enter key, which is distinct from, or next to the enter, which is distinct from the forward slash, which is next to the shift button. So for example, if we type \n, it means new line or line break. So you can see that we have some characters going on, and then we have the /n, and you can see that it breaks the line and starts a new line in the string that we get. And then we have some additional string, and then you can see that we use the \t, which stands for a tab, which is some kind of separation, which is larger than just a space. Very often it's 4 spaces, but you can see sometimes it's more. It's not exactly well defined. And yeah, and we have some more strings. We have a new line, and we have another tab, like you see here. Now, sometimes we actually do want to use a backslash within the string. And then the question arises, how are you going to do it? Because, well, like we saw, when we use backslash, it typically means for Python that we want to use some special characters. So it looks at the character after the backslash and then assigns it some special meaning. But what happens if we literally want to write a \n within our string? Luckily for us, there is a way to do that, and that is called escaping. And the idea is that if we just write 2 times backslash, so essentially \\, then Python understands that what we actually mean is a backslash. So 2 consecutive backslashes just turn into a single backslash within the string. So even though you can see 2 letters that we write here, what Python actually understands and what the string actually is just a single backslash. And you can see that indeed when we write \n, that turns into the string of \n. Now, if you want to write a whole string, and you expect to have some backslashes and other characters that you actually want them to be interpreted as they are, and you are not at all interested in all of those special characters, so you don't want to put new lines and tabs and stuff like that, instead of doing all of this escaping, which can be very confusing and complicated, you can instead just begin the string with an R. Now, this is very easy to overlook. It's very easy to miss that the way this string is defined is not the same as the way this string is defined with this small R at the beginning, but it's actually very important, and it's important to pay attention to it. What this R means, it means that this is going to be a raw string, okay? So every time that within the string we put a backslash, then we literally mean a backslash, and we don't want any escaping whatsoever here. So everything within the string is just interpreted the way it is, and we don't have new line breaks and tabs when we write this because we want a raw string. Now sometimes we also need escaping if we want to use a character that is marking at the beginning and end of the string. So for example, if we use a single quote to define a string, and then within the string we want a single quote, if we just write a single quote, then Python will think that this is the end of the string and we'll get some syntax error. But what we can simply do is, again, use the backslash syntax for escaping. And now what Python understands is that a backslash single quote means just single quote. We want the single quote to be part of the string itself and not the end of the string. And of course, another way to do it is just to use a different kind of quote to define the string in the first place. And then there is no problem. There is no reason for Python to confuse this single quote. Another thing you can do with strings is you can use the multiplication operator to multiply it by a number, and then it simply means concatenating the string to itself a given number of times. So for example, if you want to repeat the string cat space 8 times, you can multiply it by 8, and it doesn't matter if you do it from the left or from the right, you get the same result. A very important function that we use with string is the len function, standing for length. If you want to check and to get the length of a string, you simply use the len function, and you can see it simply returns the length. So if we have a string of 26 letters, then len of this variable will give us 26. And you can see that it just gives us an integer, so the type of the len of a string is just integer. Now, very importantly, we sometimes want to get a part of a string. So specifically, we might want a specific character within the string. So if, for example, we want the first character, we will use 0 as an index, and we put it within square brackets of the string that we're interested. So this syntax will simply give the first letter of the string. This will give the 5th letter, like you can see here. And now, it's very important to pay attention that, like virtually all other programming languages, we use what is called a 0-based index, which is distinct from the 1-based index. Okay, so a 0-based index begins with a 0. So essentially a 0 means the first, 1 means the second, 2 means the third, and so on. So it's somewhat non-intuitive for humans, but for various reasons it's more convenient when we do programming. And that's the reason why most programming languages will use the 0-based index. Now, this is something we are actually going to allude quite frequently in this course, and we're going to speak a lot about 0-based index versus 1-based index. And it's actually very important in biology because very often when we look into biological databases, we see that they actually work with 1-based index, okay, which is more intuitive for humans. Less convenient when we do programming. And it's something that is very important to pay attention because if you see some data in 1-based index and now you work with 0-based index, you need to do some adaptations, okay? And it's of course important not to over-adapt. So if you work with 0-based index in the first place, then it's not a good idea to do further adaptations. Okay, so we're going to speak about it quite a bit later in the course. But for now, just pay attention that we work with 0-based index. And again, since you should have some background in programming by now, then this is probably something that you're already accustomed to, okay? Now, as you can see, we can also give negative numbers within the square brackets. And what that means for Python is that we want the last letter of the string. So -1 will start counting not from the beginning, but from the end of the string, telling Python that we actually want the last letter. And likewise, -4 will be the 4th letter from the end of string, which is W in this case. Now, another thing that is important to pay attention to in Python is that when you get some specific letter within the string, the type of what we get is actually just a string. So unlike in some other programming languages where you have distinct types for a whole string or just a single character, in Python we don't actually have this distinction. So a single character is also a string. So it's essentially just a string of length 1, just containing a single character, like any one of the single character strings that you see here. Okay, so if we extract a letter from a string, we just get another string, just which happens to be of length 1. And of course, if we want to retrieve not just a single letter, but some substring of the string, we can also do that using what you see here with this colon syntax. This is called slicing. So we can slice a string and get some substring. So for example, if we want everything from the beginning of the string until the 5th letter, we can use the 0 all the way through 5 syntax that you see here, getting A, B, C, D, E. Now this may look to you again a little bit confusing because like we saw before, the 5th letter E is actually marked by the index 4. So how come here we give it 5? And the answer is that when we do the slicing, it's actually a little bit confusing. The way this works is the first index that we put is the index of the first letter that we want. But the last index that we put, the second one, is not going to be the index of the second of the last letter that we want. It's going to be one above that. So actually, when we put here 5, it means we want all the letters of index 0 through 4, not 5. So it's actually excluding this last index. And again, there are good reasons for it. There are reasons why it's more convenient this way. We're not going to get into that now. For now, just pay attention and notice that this is the way this works. So every time we use this slicing syntax, this actually excludes the last index. And we can also use negative numbers here. So for example, if we want everything between the 8th letter all the way to the 8th letter from the end, then we can use this syntax, like you see here. And we actually don't even have to provide an end index. So if we just want everything from the 8th letter all the way to the end of the string, until the XYZ, then we can just use a colon and then put nothing in the end. And Python knows it means we want everything until the end. And similarly, if we want everything from the beginning, we don't have to put a 0 at the beginning. We can just begin with the colon and then give the end index. And it will give us everything through this index. So for example, if we want the first 3 letters of the string, we can just use the colon 3 syntax. And this will slice and give us a substring of the first 3 letters, like you see here. Now, it can even grow more complicated than that. So we can actually put 2 colons and then specify not only a beginning and end index, we can also give a third number which indicates some jumps that we want to go through. So we may want every letter from the first one all the way to the 9th with jumps of 3. So we want we want the first letter, the 4th letter, and the 7th letter, like you see here. And again, we don't. If we want to begin with the first letter, we don't have to provide a 0 at the beginning. We can just do something like that, and use just a colon at the beginning. Meaning, again, we want everything from the beginning. And then again, if we want just the entire string from the beginning to the end with jumps of 3, we don't have to provide anything at the beginning and the end. We can just put 2 columns and then the jumps that we want, just with jumps of 3. And you can see we simply get every 3rd letter in the English alphabet. And similarly, if we give a negative number, then it means we want with jumps of 3, but beginning from the end and not from the start. So it will go backwards from the end to the beginning with jumps of 3, like you see here. Now, this actually can be very useful, like you see in this syntax. So maybe take a second to think what's going to happen if we ask everything, okay, no beginning, no end constraint, just with jumps of -1. What would we get? Okay, ready? Here goes. So as you can see, we simply get the exact same string in reverse order, because that's essentially what we ask. We want all the letters with jumps of -1, meaning consecutive letters just beginning from the end to the start. So essentially, we just get the reverse of the string, like you see here. And that's actually a very useful syntax that we're going to use quite a lot. To reverse things in Python, we can simply splice them in this manner. So for example, in molecular biology, when we work with biological sequences, like DNA or protein sequences, very often we represent them as strings. And as you know, very often we want the reverse, say, of DNA or RNA sequences. We want the reverse of some sequence. And that's actually a very convenient way to get it. Now, like with other types, we can convert things into strings using just the name str, which is the type of strings. So we can take a number 5 and convert it to a string, and we simply get a string of 1 letter, which is 5. Or we can take a float for 5.0 and convert it to a string, and we simply get a 3-letter string 5.0, which is the string representation of this float number. And again, these are just numbers, and we can use them and concatenate them and do whatever we want. And notice that we can also convert Boolean to strings. So here we have 6 greater than 3, which gives us true. And if we convert it to a string, we simply get true as a string. So for example, you can see we can take this string, and then, for example, we can slice the first letter. And we simply get tr, which is the first 2 letters of the 4-letter word true. Okay, and of course, if we start with a string to begin with, then converting it to a string actually does nothing. We just get the exact same string. So you can see that it's actually equals. So the original strings equals to its conversion to string, which obviously does nothing. There is also the representation function, shortened as REPR, repr. So this function actually gives not the string, but a representation of the string, which is somewhat distinct than a string. Okay, so again, this doesn't necessarily apply to string. It applies to other types as well, which can be either converted to a string, or you can get the representation. And although both of them will give you some string representation of a string, it's not exactly the same string, like you can see in this example. So actually, the string itself is just the string, but the representation also contains the quotation marks. So this is something that you can actually copy-paste into some Python code, and you will get the string. Okay, so you actually need the quotes at the beginning and at the end. So that's why the string representation of a string is not actually the string conversion of a string is not equal to its representation, like you see here. The representation is actually what you get when you just, for example, in Jupyter Notebook, and that's the same also in other interpreters like in IPython, when you just write down some variable or some expression, and it just gives you some output, like you can see here. Okay, so instead of printing s, printing does something else. It just prints it to the screen as it is, so just the string itself. But if you just write it and keep it hanging there, and you execute the cell, running the cell, then as you can see, what you get is actually the representation of the string, not the string itself, which again can be more convenient, because then you can just copy paste it and into some other Python code and just work with it. Okay, again, we are going to look into it more deeply in other contexts as well, but for now pay attention that a string representation, sorry, the representation is not the same as the string conversion, specifically in the string case. Okay, and like with numbers, we can use the plus equals and multiply equal operators to perform an operation on the string itself. So for example, we can take the string and we want to concatenate it, 1, 2, 3, and a tab, and then to assign the result back into S. So again, like in the case of numbers, this is completely equivalent to writing it this way. Okay, so taking S, concatenating it, this thing, and then assigning it back to S. These two lines are completely equivalent. This is just a short way, a nicer way to do that. And likewise with multiplication. So if you want to concatenate a string to itself multiple times and then assign it back to the string, you can use the multiply equal syntax. Okay. Now, as you can see here, sometimes we want to define very long strings. And so let's say we just have this very long string. As you can see, it extends the typical width of a Jupyter cell. So we actually have to scroll it to see everything that is written here. And this is very inconvenient, especially if it exceeds by a lot. So typically we don't want to have this horizontal scroll bar within Python. If a line extends too long, then it's not very easy to read it. So it's better if we have very long lines in Python, we can simply break them. And one way we can do that is simply by concatenation. So we can just end a string here and then concatenate it the rest of the string, and then we can just break the line. And now it all fits together into this one line. So I actually recommend you to do that. Don't write very long lines in Python. If you have very long lines, then break them. For example, using this concatenation syntax. And also note that we use a backslash here. Now sometimes it's not required, but sometimes it is. I recommend you to always use a backslash in this case. And in this context, if you use a backslash, just, not within a string, but just, within some Python code, what it means for Python is that this is a line break. You simply want the next line to be treated as if it was the same line as this line. So when Python reads that, what it actually sees is just a very long line. So it treats these two lines as if they were written on the same line, okay? Because we have the backslash here. And then we get this very long string, and there is no problem. It all fits into the width of the cell here. Okay, so another way to write very long lines, we saw this syntax that we can use for comments. So we can simply put 3 times quotation mark. Again, it can be a single or a double quote. And then everything you write in between will turn into a very long string, including line breaks. So this is another way to introduce a very long line, and here you don't even have to end the string and to concatenate it and to break the line. You could just write it until you end it. But there is a difference. This thing and this thing will not turn into the same kind of string, because here the final string that we get is actually going to be just one very long string without any line breaks. Where on the other hand, what we get here is actually going to be 3 different lines. So actually Python knows that we have those line breaks, and it keeps them as part of the string that we get in the end. Okay, so not exactly the same thing. And the final thing I wanted to show you concerning strings is that we can use the in statement to check whether a substring occurs within string, and it just returns a Boolean number. So you can see we have a string, we have some other string that we suspect is a substring of the first string, and then if we write substring in string, we get a Boolean that tells us whether the substring is indeed a substring of this greater string. And in this case it is. You can see that n space el indeed occurs as an exact substring within the string. But if we slightly change it, if we put, say, this thing, you can see this is no longer a substring because we have this n at the middle. So we don't have those exact four letters in this exact order within this string. Okay, so that's everything I wanted to show you for now about strings. Now let's speak a little bit about conditions and loops in Python. So yeah, again, this is very similar to other languages you might have seen, probably have seen, assuming that you have programming experience. So essentially the way this works, we already saw that we can take two numbers and we can compare them and get some Boolean or true or false, and then we can simply write an if-else statement. So essentially, if this ends up being true, then the branch of the if statement is going to run, and if not, then the branch of the else is going to run. Now, since in this case A is indeed greater than B, we're going to get this code running, not this code. But if it were the other way around, we would get this thing running. Now here, for the first time, we have something that is called opening a new block in Python, like you can see here. So the way this works, after we introduce an if statement, we actually begin a new block of code, like you can see here. And you can see that we have some indentation here. It has to be indented in some way. We need to have some spacing to indicate to Python that this is indeed a new block that we write. So unlike in other languages where you don't really have, it's very often the convention to use indentation, like in C or Java, in Python it's actually enforced and it's a must. So you can see that if we use an if statement and then we don't indent the code following this if statement, then we get an indentation error saying that expected an indented block because we have an if statement. So it has to be put forward, like here. Okay, now Python is not strict about it, so you can use a tab like this, or you can use a space. And either way it should work as long as you are consistent about the kind of indentation that you use. Now you can see that Jupyter doesn't actually like that. So here we actually use a tab indentation, which is what is typically expected, or 4 spaces. But if instead we use just a single space indentation when we begin a new block, then this will work, but you can see that Jupyter doesn't like it. It indicates it in red. Okay? It says that this is not the convention to use this kind of a single space indentation. Okay? We need to use a whole tab for Jupyter to be satisfied, and that's the way we should work. Okay? So we need to have sufficient indentation, and I think it's also nicer and more readable because now it's very clear that we have a new block. One space is usually just not enough, and it can be confusing and very hard to know how many indentations you have. Okay, and another very important aspect is the column, which tells Python that, again, we begin a new block. So if we forget to add columns, we get a syntax error, invalid syntax. And now, if you're not used to programming in Python, I suspect that you're actually going to encounter this kind of error quite often. And again, you can see that it can be somewhat confusing to understand what's going on here, because Python doesn't explicitly tell you, okay, you forgot to put colons, pay attention to it. It just tells you invalid syntax, and you need to figure out on your own what it refers to. A nice clue that Python does give you, you can see this arrow here. It indicates the exact location of where the error occurs, and you can see that this is right after the if statement. Okay, so this is an important clue that you forgot to add columns. Okay. Now you can, again, you can put multiple conditions one after the other. There is nothing nothing wrong about it. Okay, so you can just, you have one condition and a second condition, And you can put one if statement and then another if statement, and each of them is evaluated independently. And you can see that the indentation is also appropriate. So you can see that this if statement and this if statement are independent. Okay, whereas, for example, if we indented that, then this would be part of this if statement, and now this code would be evaluated only if this condition was met. Okay, so this is not the same thing. Again, this indentation is very important in Python. This is the way we indicate where a block begins and where it ends. And a second thing to note about this example is that here we don't evaluate the conditions within the if statement themselves. We evaluate them beforehand, getting a Boolean value, and then just using a Boolean value within the if statement, okay? So again, this would be equivalent to evaluating it within the if statement itself. We can do it like that. Or we can first evaluate it, getting a Boolean, and then just use the Boolean. Now you will very often see beginner programmers writing some code like if some condition equals to true. And I think that this might be intuitive to beginner programmers because they're used to if statements being some expression, and here they want to check if this condition is true, so they just compare it to true. But in reality, there is really no reason to do that. Okay, so if you already have a Boolean, you can just use the Boolean itself as a condition, and that's actually the proper way to do it. Just use a Boolean. And again, we can have many conditions, one after the other, and you can see that we have this condition met and also this condition, and since all the four are independent, each one will be evaluated independently of the other. Now, sometimes we don't want that. We actually want just one of the conditions to be met, and if one of them is met, we don't want any other of them to go on. So for example, we might want, okay, if we have this condition met, then this is sufficient for us. We don't want to have another one checked. And there is actually a way you can do it. You can do it using the else if statement, which is shortened in Python into elif, that you can see here. So this five-letter elif means else if in other languages. Okay, and what essentially it means is we have some condition. If it's met, great, then we will run this code. If not, else if this condition is met, then we want this to run. And if this is not met, we want to check this condition and then run this code, and then maybe check this condition and running this code. And if none of the conditions is met, then we want to run this default code. And as you can see here, we get here, and then this thing is run, and then we stop. We don't evaluate any other condition because it's actually all part of the same if statement. Okay, so this is a very long if statement ensuring that only one of these conditions is going to occur and only one of these blocks is going to run. And by the way, we don't need an else at the end, so we can also have just if, else if, else if, else if, and it's fine. Okay, so if one of them is met, we will get the code running. If none of them is met, we will get none of it running. And like we saw before, we can have blocks within blocks. So there is really no problem to have one if-else statement within another one. So we can check something and then check another thing within it. So in order for this code to run, we need first this condition to be met and then this condition to be met. And if it's not met, then we get here. And if the outer condition is not met, then we will get here. So we can think about it as some kind of tree with some branching conditions that in the end you will get to either one of them. So you are guaranteed to end up in either of those three blocks. Now sometimes you can do it a different way using the Boolean operators that we saw before. So you can actually notice that this code is completely equivalent to this code. So here, instead of putting an if statement within another if statement, we simply put the two conditions together with an AND operator between them. And this else statement will just be the not of this second condition. And this thing will be just the else, the default. And if you look at it logically, or if you think about it a little bit, you'll see that these two are completely equivalent. And each of them has their own pros and cons. So going about this way spares us the need to use these Boolean operators, but we end up with a more complicated branching. And here we avoid these nested conditions that we see here, some conditions within conditions, but we end up needing to use those Boolean operators instead. Okay, so which one is better is actually a matter of taste, and I suspect that in some cases it will be more convenient to work in this way. In some cases it can be more convenient to work in this way. Either way, it's fine. Okay, so that was conditions. Now let's speak about loops. Again, I'm pretty sure that you're used to it from other languages, so we're going to do it very briefly. So actually loops in Python, again, work somewhat differently than in other programming languages. Again, if you work in C or Java or a programming language like that, you might be more used to the old-fashioned kind of for loops, which had some starting condition, some end condition, and some incremental condition. In Python, what we have instead is just what is sometimes known as for each syntax. We simply give it some collection of elements, like a string in this example, and then we just iterate through this collection using the for some variable name in collection, like you see here. So in the case of a string, what we end up getting is just iteration through every single letter within this string. So you can see that if we do for s in string, on each iteration s will get the value of the next letter within the string, and then we can print it and get all of the letter of the string, one within each line. Okay, so let's see a more complex example. So let's say we have some DNA sequence, like you see here, and then we want to count how many A's we have within this sequence. So we initiate an A count variable. We put it to 0 at the beginning, and then we use a for loop to iterate through all the letters of the string, meaning all the nucleotides within this DNA sequence. And for each nucleotide, A, T, C, T, and so on, we compare it to an A, and if it's equal to A, we increase the count by 1, like you see here. And then in the end, we print it, and you can see we have 9 distinct A nucleotides within this DNA sequence. Of course, if we want to do something as simple as that, just counting how many letters of a given type we have within a string, we actually have a built-in function to do that. We can use the DNA count function. So within the DNA variable, we use its count function, like you see here, and we give it an A, and it actually counts how many of this string occur within the DNA string. It can actually receive any substring, so it doesn't have to be just one letter. It can be also be 2 letters, like you see here. And then it will just count how many times it has A and a T as an exact substring, one after the other. So you can see we have one here and another one here, and altogether we have 4 of them within this DNA sequence. Okay, another kind of loop that we sometimes use in Python is the while loop. Now a while works differently. In a while loop, what we actually have is just a condition, and it runs as long as this condition is met. Again, the name while is very appropriate. So let's see an example. Let's say, again, we want to count how many A's we have within this DNA sequence. So we initiate a count to 0. Now we also initiate an index I, and we put it to 0. And now as long as this index is smaller than the length of the DNA sequence, then we take the DNA sequence at the ith index, so essentially getting the ith letter of the string, meaning the ith nucleotide. We compare it to A, and if it's an A, we increase the count by 1. And at the end of each iteration of the loop, we increase I by 1. And you can see we get the same result. We get A count to be 9. Now the way this works is, again, we start with our I being 0. We So we get the first nucleotide, we then increase it to 1, we get a second nucleotide, we increase it to 3, and so on, until this condition is no longer met, and we exceed the length of the string, and then we simply stop. And you can actually see that in this kind of for loop, we have this spillover effect that we actually have the I index still used. So it's still defined after we finish this for loop, this while loop. You can see that by the end of the loop, we get it to be 24, which is exactly the length of the DNA, and that's why this is the first iteration for which this condition is no longer met, and then we don't run what's within the loop. Okay, because 24 is the length of the DNA sequence. Now, of course, in this case, I think it doesn't make a lot of sense to use a while loop. It's more convenient, as you can see. It's more readable to use a for loop, like you see here. I think this is the recommended way to go about it. And as a general guideline, as a rule of thumb, what I recommend you is that if you have a loop that needs to run a given number of times, so if you know in advance how many times you need to run this loop, so for example, if you know that you need to run exactly the number of letters that you have within some string, then it makes sense to use a for loop, not a while loop. A while loop, I think, only makes sense if you don't know in advance how many iterations you will end up needing. So let's see an example for that. So let's say we want to generate random DNA sequences that have exactly 9 A's within them. Okay, so I wrote this code and I will run it a number of times. And you can see that each time that I run it, I get a different length of a DNA sequence, but I get that it has exactly 9 A's. So you can see one time it's shorter, and then it's slightly longer, shorter, shorter, and much longer. So every time we get a different length. But we are guaranteed to always end up with exactly 9 A's within this DNA sequence. Now this actually makes sense, because if we want a DNA sequence which has exactly 9 A's, it doesn't predetermine what the length of the DNA must be. Okay, so in this case it makes sense to use a while loop, and let's see how we can use a while loop to achieve our goal here. Okay, so we initialize a synthesized DNA string as an empty string, and we keep track of how many A's we have introduced into the DNA sequence. We begin with 0, and as long as we have less than 9 A's, we want to continue. And now we use the random package that you see here. So we import random, and then from random we use the randint function that you see here. Now what the randint function does, it produces a random integer. And it's going to be an integer between 0 to 4, not including 4. So again, this is like we saw in slicing, that actually the last index is not used. So essentially it's going to be 0, 1, 2, or 3. Okay, all the 4 options. Now according to this number, we're going to decide which nucleotide we want to synthesize. Okay, so if it's 0, we're going to put an A, 1 will be a C, 2 will be a G, and otherwise 3 will be a T. Now if we add an A to the synthesized DNA, we also want to increase the count of A by 1. And that's essentially it. We simply go, so on each iteration we introduce a random nucleotide, and we stop once we have introduced 9 A's. Okay? And now it makes sense to use a while loop, because again, we don't know how many iterations we need to put, so we cannot use a for loop here. We must use a while loop with some conditions that tells us when we need to stop. Now, I would say that while loops, because we don't know in advance how long they're going to run, and it depends on conditions, it can be sometimes quite dangerous to use them, because this may result in infinite loops, like we see in this example. So here you can see we just write while true. So true is always true, and so this loop never stops. So we begin with I being 0, we increase it to 1, 2, 3, 4, and you can see it goes on forever. If I don't stop it, it will go on indefinitely. But now that I see it, I can just stop it. You can see I have this stop button here. I press it, and it doesn't work. Why doesn't it work? Yeah, sometimes Jupyter takes a while to respond. Let's interrupt. Nope. Okay, so it appears I don't have a problem. I think I will have to restart the kernel. And now we forced it to stop. Okay, so we had to restart the whole thing, the whole notebook. Okay, now I don't know what exactly went on here. Sometimes Jupyter has its own capricious mindset. But typically, if you want to stop something, you just run the interrupt kernel. Typically, it should work. I don't know why it didn't work now. I think something might be wrong with my environment or the browser or something like that. Now, actually, as you can see, I used here the time sleep function. So again, a time is some package that I can import, and within it, I have the sleep function, which I can give it some number of seconds, and then what sleeping means is just telling Python that I want it to do nothing for a whole half second in this case. And that's actually very important, because if I didn't use it, it would go much, much faster. So instead of making, like 167 iterations, it would have maybe hundreds of thousands of iterations. And it would actually be much worse, because now on top of everything, I would also have my console flooded with too much text printed. So when I have too much text within output, it can also cause troubles. And in very good probability, this would completely crash my notebook. And whereas typically if I just press the interrupt kernel, which didn't happen now, but believe me, that typically does work. When I press it, then it stops the kernel, and I can just, continue. If I didn't put a sleep, then I can pretty much guarantee to you that it would crash this notebook so badly that I would have to restart it. And not only that, I might also have to clear all the output, and maybe open it, and maybe even restart the whole Jupyter process, because it would be so bad. So it's actually a good thing that I made sure to sleep if I have an infinite loop. And that's actually something I recommend you to do. So if you write a loop and you're still in the process of debugging it, and you suspect that you might be doing something wrong, and you might make it run for an infinite number of iterations, then I recommend you to artificially put this sleep in the end of the loop or somewhere else, in order to artificially slowing it down, making sure that it doesn't get completely out of control, and that you can interrupt it and you can debug it more sanely. And as long as you debug it, just keep the time sleep there, and only once you are finished, once you see that everything works fine, you can remove it and just let it run indefinitely. Okay, let's see some more syntax which is related to loops in Python. So let's speak about the continue, break, and also pass, which is actually not related to loops. Okay, so within a loop, it could be either a for loop or a while loop. We can use the continue and break keywords. What they mean, a continue simply means that we want to interrupt the current iteration of the loop, and we want to go straight ahead to the second iteration. So you can see in this example, we iterate through all the letters between A to K, and every time we want to print them. But when we get to D, we use continue, meaning that this loop will no longer be evaluated. So this iteration will stop here, it won't get to printing it, and we go straight ahead to the next letter. So you can see it prints A, B, C. When it gets to D, it's not printed, and we go straight to E, F, G. Now, similar but very different is the break statement. When we get to I, not only we want to stop processing this iteration, we also want to exit the loop altogether. So breaking means we want to end the loop right here. So when we get to I, it's not that we not only get to print I, we also don't get to J and K. We actually stop here, and nothing is processed anymore. Now, another kind of syntax that I wanted to mention is the pass statement. Now, a pass actually, what it does nothing. Okay, so it's simply a placeholder for some block. And the reason that it's needed sometimes is because, for example, if here we had this else statement and then nothing afterwards, we would get an indentation error saying we expect some indented block after this else. But if we don't actually want to do anything, then we need to put something within this block. So we need to use a pass statement. Of course, in this example, this is quite silly because we didn't even need to write this else. We could just eliminate these two lines altogether, and it would just work the same way, okay? So in this case, it wasn't really necessary. But sometimes we do need to open a block, but we don't want anything within the block, and we need to put a pass statement within it. I think we are going to see some examples in future lessons of the course. Now, final thing concerning loops that I want to show you is that we can have what is known as nested loops. We can have one loop within another loop, and we can actually have more than two loops even. So you can see here we have an outer loop that is iterating through letters, and we have an inner loop that is iterating through digits. And what we end up getting is we get all the combinations of these two. So a loop of 3 iterations within a loop of 3 iterations. So altogether we will get 9 iterations. So within each one of these iterations, we're going to get 3 iterations of this inner loop, like you can see here. So we are supposed to get all 9 combinations. Now, of course, in this case, you can see that we actually put a break statement, which is the reason why we don't end up with 9 combinations here. So when we get to S1 being A and S2 of the inner loop being 2, we put a break statement. Now, what I wanted to highlight here is the fact that the break statement, and this, by the way, also applies to the continue statement, they only affect the most inner loop of where we currently are. So in this case, the break statement will affect the inner for loop, this one. So when we get here, we will have this for loop breaking, and we won't get to S2 being 3. So you can see that we don't get A3, we just get A1 and A2. But this doesn't exit the outer loop. So after we break this loop, we get to the next iteration of the outer loop. We get to B, and within B we get all the normal iterations of the inner loop, and also for C. Okay, so pay attention that break and continue only apply to the more inner loop. Now, if we want to break an outer loop, there is actually not a very convenient way to do that. We might need to introduce some kind of Boolean variable telling us that we want to exit. And that's actually complicated. We're going to see in the future how we might overcome this, but we need to use some other trick to exit the loop. We cannot use the simple break syntax.